says, let's look at number 10, shall we? What could possibly be my favoriteest of all problems? Number 10. Number 10. The question is, what is the probability that an object that lands in the parallelogram also lands inside the trapezoid? And if you remember, that's a pretty simple little concept because probability is a fraction. What is the fraction going to be? It's going to be the probability, I'll make this a little smaller, the probability that, probability of, it's going to be the area of the trapezoid over the area of the parallelogram. In which case, it's probably good to know the formula for a trapezoid, which I don't know if we had this year, but we get to it, or we did last year. Area of a trapezoid is 1/2 base sub 1 plus base sub 2 times the height. And the area of a parallelogram is simply base times height. Ain't that exciting? Base 1 and base 2 with trapezoids are the two parallel lines. 2 and 2. Which means, we have to kind of assume, I'm guessing that this is 10 here, because 10 can't be this line, because 16 is that line. So the trapezoid would be 1/2 of base 1 plus base 2, 10 plus 6, times the height, which is this right there, 6. So 10 plus 6 is 16. You can take half of anything you want. Half of 16 is 8, and then 8 times 6 is 48. So on your probability, you get 48 on top. Did you get that? Let me do that again. You can say stop at any time. All right. And then the probability of the parallelogram, this bad boy shape right here. Remember, base and height have to be perpendicular. So your base is 16, not 10. 10 was for that trapezoid. And the height is 10. So it is simply 10 times 16, which is 100. And I assume you just reduce that. 8 goes into both of them. 6 over 20. 2 goes into both of those. 3 over 10. Stop me there forever, hold your peace. If something makes sense to you, make sure you write down those formulas. It's pretty simple. Trapezoids, parallelogram. Pretty sure it'll be there tomorrow. How many people got that right? Oh, a few. Or more. Riley to number 2. Look at that. And I suppose that is also the volume of a sphere. Make sure you have that formula down. What is the volume of a sphere? What is it, pi r cubed? Or is it 4/3 pi r cubed?
4/3
pi r cubed. 4/3 pi r cubed. Or, if you want to write it like this, it's the same thing. 4 pi r cubed over 3. Same exact thing. All you need to know the volume of the sphere is what its radius is. And what is the radius of that thing? It says the sphere has a diameter of 6. So if it has a diameter of 6, its radius is just 3. So 4 times pi times 3 times 3 times 3 all over 3. The beauty of that is one of those 3's will cross off with this 3 on the bottom. 3 times 3 is 9 times 4 is 36 pi's inches cubed. 36 pi inches cubed. Again, stop me there if that didn't make sense. The only thing you need to know, make sure you have this formula written down. And then I suppose you might as well do 3. I believe 3, the surface area of a sphere is 4 times what it is, the area of the circle that it would be. Is that alright? You tell me if I'm wrong here, won't you? So 4 times pi times 3 times 3 also gives you 36 pi's. So it's in Squared units not in cubic units. 4 again, let's not talk about. We'll try to sweep that under the carpet. That's it? Wow, Elijah.
Numbers, give me number 6, please.
I hope so. I'm going to make a slight go around. Yeah, draw the line through 2 and 1. What is the slope? What is the y-intercept? You will do this on some sort of graph paper. You don't want to do it like I'm doing in here, but I will show you. It shouldn't be too bad. You're plotting both of these points, 2, 1, 1, 2, 1, negative 2, 3, negative 2, 1, 2, 3. You are plotting the point, and they're asking you for the y-intercept. Y-intercept at where it crosses the y-axis, which is right there, which apparently to me looks like the y-intercept equals 2. Crosses the y-axis there at 2 would be my guess. And then the slope. Slope is the rise over the run. How high over how long. You're just going to make a triangle out of these points and figure out how high it is and how wide it is. It's going downhill is the first thing that you want to know, so your slope has to be negative. Why do you get so big? Did I do something? How high is the rectangle triangle? 2. How wide is it? 1, 2, 3, 4. So it's negative 1/2. That is its slope. Again, stuff we did last year. This is not. This comes from lesson 56, children. You did 56 probably back in. Well, right now we're on 38, so around Christmas time, January of last year. Winkleman.
How do you do number 18?
Oh, my second one. Negative 2/3 cubed. It's not a negative exponent. You don't be flipping anything over. Negative 2/3 cubed just means that you have negative 2/3 times negative 2/3 times negative 2/3. Negative times a negative times a negative gives you a negative. 2 times 2 times 2 gives you 8. 3 times 3 times 3, 9 times 3 is 27. 8, 27. Do you overthink that one? Because that one to me doesn't seem to be that difficult. Others could be. 13. 13. Now this one is one you want to focus on. I'm going to guess most of you didn't get this right. How many people got this right? Without the aid of somebody else. 3x plus 4 is greater than less than 4x. First thing you have to do is you solve this just like a normal equation. So you want to get x by itself. Well, you run into some issues here. I suppose the easiest way to do this would be to do this. Subtract 3x, correct? Subtract 3x, and what are you left with? 4 is greater than or equal to x. Now, the problem with that is when you work with inequalities, the x needs to be on the other side. We never say 4 is greater than x. We always say x is either greater or less than something. Okay? And what you have to remember here is, see Mr. Alligator? Mr. Alligator always eats the bigger number, yes? If you flip x and 4 around, Mr. Alligator still should be eating the bigger number, which is still 4. So this sign, if you flip them around, the sign flips around as well. Kind of like it's rotating on a little axis there. So that is that solved. And then when you graph it at 4, there's a closed dot, and it goes in this general direction. Does that help? You could have, I suppose I should show this to you too. 3x plus 4 is greater than or equal to 4x. You could have moved your x's to the left side, but what happens if you do that, and subtract the 4x and subtract the 4x, you get a negative x over here, and then you have to move that 4 over there, which means you have to subtract 4. You end up with this, which is a little goofy in itself, because another rule of inequalities, just like equations, you can't leave this you can't leave this negative. So this changes to its opposite, this changes to its opposite, as does this. They all change to their opposites if you were to solve it that way, but you still get x is less than or equal to positive 4. Hip hip. Josh. 9 or 19? 90?
Somebody could have told me that.
Anybody? How am I gonna do this? Number 9, you're gonna want to graph those two lines. See where they cross. You could do trial and error, that might take you a while, I don't know. Again, graph paper would be good tomorrow. Maybe I'll shoot you a piece, help you out. How do I graph this first one? Actually, how do I graph both of them? Those are both in standard form, so you do what? X and Y intercepts. Just be careful with it. For the first one, where's the line cross the x-axis? Somebody say 8, because I didn't hear them. 1, 2, 3, 4, 5, 6, 7, 8. Where does that line cross the y-axis? Somebody say 4. I didn't hear them say that. 4, yes. 1, 2, 3, 4. So there's your first line. Second line, gotta be a little careful with because there's a negative in there somewhere. First of all, crosses the x-axis at 1, no negatives there, 3 goes into 3 ones. And it crosses the y-axis, here's where you gotta be careful, because it's a minus y, it crosses at a negative 3. So negative a 1, a 2, a 3. You will graph that. And if I were to guess a man based on my poorly sketched graph there, there's supposed to be 2, 3?
Yes.
Yeah, I was a little off on that thing. X equals 2 and y equals 3. Or 2 comma 3 would be the same thing. If you put 2 and 3 in these, they'll both work. It's the only combination of things that'll work. Yeah. So graph and find where they cross. I get a good feeling about this test. Not real good, but kind of good. Kate.
Number 1.
Number 1. Oh yeah, this one. Again, this one's kind of an overthinker. I would have sat down and drawn pictures forever there until I realized that this is an example of, this is inverse variation. Simply for the fact that if you go at 3 miles an hour and you walk in 15 minutes, if it takes you less time, you're walking at a faster rate. As one goes up, the other one goes down. When you talk about speed and time. The faster you go, the shorter amount of time. So you have to think about that as inverse variation. Then you just need to create a little table here. And put speed over here and time over here. The first one, her speed was 3, and it took her 15 minutes. So you know right away, no matter what happens, when you multiply your speed times your time, you must get 45, no matter what the pair is. In this case, she jogged home, her time went to 9 minutes. So you just have to say 9 times what number here is going to give you 45, and that is 5. If her time was only 1 minute, how fast would she have to be going? 45 miles an hour, which is a pretty good clip. if her speed was, if her time was 0, how fast would she have to be going? Nope, it'd be impossible, you couldn't do it. No possible way of going 0 to getting there in no time at all. It's impossible. Huh? Here would be a question, to get there in a half of a minute, how fast would you have to be going? 90 miles an hour. To get there in a fourth? How many miles an hour? 180. To get there in a tenth of a minute? 450 miles an hour. To get there in 1/100th of a minute? Oh, to get there in 1 second?
It's not possible.
That's a 60th of a minute. You'd have to go like 25,000 miles or 2,500 miles an hour or something like that. So that these two multiplied together would be pretty fast. Elijah?
Could you do number 7 very slowly?
Very slowly?
Very slowly.
Alright, will be my slowest bet. List the 3 angles in order from least to greatest. You just have to know that sides and angles are related. I should say sides and their opposite angles are related. In other words, the angle opposite the smallest side will be the smallest angle. And vice versa. So if you look and find the smallest side, which is this one, the angle that is opposite of it has to be the smallest angle in the triangle. And the next smallest side was this, so you go angle opposite of that. So angle C would be the smallest, then angle A. The biggest side on the triangle is that one, so the angle opposite it is the biggest angle. So this would be the order from least to greatest. If the ask you the other way around, it would be the other way around. Which only makes sense if you kind of draw out triangles. You know, you've got this little teeny tiny side right here, and this triangle is like that long. The angle opposite that is super small. Opposite angle, this one is a lot bigger, and so on, and so on. Jason, was that your question?
I was gonna ask about when.
Who? Oh, the last one, number 20. Six times the square root of 6 times 8 times the square root of 8. You could multiply them together, but then you're just gonna have to factor them again, so I don't know if that's gonna be a whole time saver for you. Right off the bat, you could multiply the two numbers together. You know you're gonna have a 48 here for sure. Okay, but then I would probably factor these out. The square root of 6 is the square root of 3 times the square root of 2. You with me? And the square root of 8 is the square root of 2 times the square root of 2 times the square root of 2. Are you with me on that, Jason?
Yes.
Okay. Well, if you have identical square roots, square root of 2 times the square root of 2 is the square root of 4, which is a normal 2. Square root of 2 times the square root of 2 again is 4, which is a normal 2. The one square root that doesn't have anybody to cancel out is the square root of 3, so it stays. Then you remultiply the numbers. 2 times 2 is 4. 4 times that is 192, I believe. Square roots of 3. Or you could multiply it and get 48 times the square root of 48, but you're still going to end up with the same thing. Break it down. Want me to do 19 right above it, or no?
I'm sure.
Nah. Sure, somebody says. I would suppose the first thing you want to do is make this a positive exponent by moving it to the top. It becomes b to the first. 5 goes into 25, 5 times left on top. Oh, look, this 1m crosses off with one of the 4 m's up there to leave you with m to the third. B squared times b is also b to the third. Nothing left on bottom. Score. Winkleman.
Number 8.
Over at number 8 at one time. Algebraics for the area. It's a square. By definition, a square has 4 equal sides. The actual area of a square, you can think of 2 ways. It's either side squared, or you could call it side times side. Either way, make sure you put this in parentheses because that ends up being 2x minus 3 times 2x minus 3, which in the mathematical world we call that a binomial times a binomial, and when we do a binomial times a binomial, we use what little handy dandy little an acronym, Grace?
FOIL.
Right, RAS, foiled again. Which is nothing more than saying every term of the first one times every term of the second one, but this is just an easy way to kind of remember it. If you multiply the 2 first terms together, you end up with 4x squared. If you multiply the outside terms together, you get negative 3 times 2 is a negative 6x. In the middle, the inside terms, you get another negative 6x. And then your last term, when you put it together, negative 3 times a negative 3 is a positive 9. Generally with FOIL, the 2 middle terms will combine. A negative 6 and a negative 6 is a negative 12x's. You still have the 4x squared out front, and you have the plus 9 at the end. Nothing simpler than that, is there? That is your area, whatever it is, in inches squared or units squared or something squared. It doesn't really say what it is. But I thought that was probably something. Oh, I do. Okay.
Number 16.
Oh, Kate says 16. How much time we got left? 16. Is it right here? Oh, my favorite. Kate, what should I do first? Yep, how do I get rid of those parentheses? What property? Boardwalk or Park Place? What property do I use to get rid of those?
Oh,
Yes, the distributive property. So you're going to multiply 2 times x and get 2x. 2 times a negative 3, get negative 6. You still have the plus x, you still have the 4x plus 2. The next thing you want to do is look on each side and see if you can add any like terms, which I can. I have 2 x's here and another x, and that's 3 x's. I kind of simplified both sides. Now I am going to do what? What would you do, Elijah?
Get rid of the x, it's on the right side.
So you're going to subtract this one? So you subtract 4x, subtract 4x, which gives me a minus x, which is not ideal, but we can deal with it. And since I moved the x's to the left side, I'm going to move the numbers to the right side. I'm going to do the opposite and add 6, then add 6. So negative x equals a positive 8. Flipping stuff around. If a negative x equals a positive 8, a positive x equals a negative 8. Manuel?
17.
I was hoping somebody would ask 17. Just know this, see this little squared? Maybe I should make it bigger. See that big squared? See that little 2 there? That means whatever's inside the parenthesis gets multiplied twice. So you end up with 4x cubed times 4x cubed. What is 4 times 4? 16. What's x cubed times x cubed? X cubed means you have 3 x's times themselves, and this x cubed means you have another 3 x's times themselves. That is a total of 6 x's times themselves. So that whole thing simplifies to 16x to the 6th. Don't get not no better than none of that. Everybody got this one right? Want me to do this one?
Yes.
Oh, there was a yes. Okay. I kinda like these. Anybody else kinda like these?
No.
If you follow the steps, they're really not too terribly bad. Step number 1 is set an f equal to that. So f equals 0.36. Both 3 and 6 repeat. However many digits repeat, that's however many zeros next to the 1 you multiply that by. So since there's 2 digits there, you multiply by 100. 100 times f is 100 f's. Here's where most people make their mistakes. When you multiply this by 100, the decimal moves 2 places to the right, therefore leaving you with a 3 and a 6 to this side of the decimal. And then the 3 and the 6 keep repeating, so that's what's left on the other side of your decimal. And you subtract them, and your whole goal is to get the repeaters to go away, which they do. A 0.36 repeating from a 0.636 repeating gives you nothing. 0 from 36 is 36. 100 minus 9, or 100 minus 1 is 99. So then it's just solving for f, divide by 99, divide by 99, you get, 3 goes into both of them, 12 over 33, 3 goes into both of them, 4 over 11, 4 11ths. And that is why, children, I have to take this, that is why this is a rational number. It is not irrational like pi. The difference between rational and irrational. Rational numbers are repeaters, which would go on forever, but they're repeaters. Irrational numbers go on forever, but there's no repeating to them. Every repeater can be changed to a fraction, which makes it rational. In case that ever comes up on any quiz bowl question. That might come up. Is 0.36 a rational number? Yes or no? Maddie, Ron?
14.
Is that on this page here somewhere? Nope, over here somewhere? Is it over here? Expanding. Whoa. Is this all it is, expand this? So again, it's just distributive property. This times this, and that times that. 4 times 3 is 12. M times m squared is m cubed. Take the minus sign from here, and 4m times 2 is 8 m's. Did you something?
No, I'm just saying bank account.
Say bank account? Eight m's?
Yeah, 8
Why does that mean bank account?
8 M's in the bank account.
8
Million.
Is that some slang that I don't know?
It's a song.
Oh, okay. Other ones. Speak it now, or if I never hold on keys, what have we done here? Remember, you're also asking for all the little schools that never had the chance to get here. Oh, 12, that's just a no-brainer. Solving for x, on number 5? I'm listening. No?
Can we do number 5?
Are you serious? Are you just patronizing me, or are you serious?
No, I'm trying to waste some time.
Oh, I know.
Well, I wish you'd waste your time and get these right as opposed to that. Oh, so you will have your ratio of the lengths of the side opposite to the A to the hypotenuse, so make sure you have your trig functions with you. What are we looking for? Oh, I guess we don't need our trig functions because it just says side opposite. We're looking at angle A, that's important. Oh, look, side opposite, there is no number for side opposite, so you have to find that. Is that a Pythagorean triple? Yeah, it looks like it must be 4 inches. Opposite of A is 4 to hypotenuse 5. I knew that, but that'd be a struggle for Elijah. You got it now, Elijah?
I already had it.
No, you didn't. Why would you ask about it?
So I was making sure I did all the steps correctly.
Yeah, apparently so. Do you have one as well? We have many that we haven't done. 15. But you probably want to say hi to all those people that aren't here because they're probably going to watch this online.
Hello.
Oh, we could sing, but after we do this problem, we'll sing.
Interactive experience.
Let's make sure we get this one right. 25 minus x squared equals 9. Again, you're solving for x. If you want to subtract 25, you subtract 25, which is good. You get a negative 16. That's a great thing. If it goes positive, you struggle. Change this to its opposite, it's x squared. Change this to its opposite, it's 16. So x equals, by the way, the thing you're doing that actually makes this work. Why does that equal 4? Because just like when you can multiply both sides of the equation by something, you can also take the square root of both sides, which is what you're really doing with that. The square root of x squared is x, and the square root of 16 is plus 4 minus 4.